Welcome. My pen, yes. So, this question says a student pulls on a moving 4 kilogram bag with a force of 6 newtons at 20 degrees above the horizontal. The bag continues to slide 3 meters across the level rough floor. How much work was done by her 6 Newton pulling force during this period? And here's a diagram at the side. So let's just try to visualize this a little bit. So the bag's sliding, it's sliding to the right, and what happens is at a certain position the student grabs it and is pulling to the left and upwards with 6 newtons. The bag continues to slide to the right, and the student continues to pull with the same force at the same angle during this displacement process. So the question is, and you know what's going to happen. What's going to happen is the bag probably is going to slow down, maybe stop, maybe not. In effect, our work is taking energy out of the bag as represented by a lower velocity. And we'd like to analyze this in terms of work. So what we do is we redraw a diagram. So we have basic little block 4, and then this guy is up here. Let's try and get that a little bit better. So we're going to have and this is going to be 6 newtons, and this is going to be 20 degrees. And there's going to be a weight of 40 newtons, and there's going to be a normal force, and yes, there's going to be a frictional force because it's a rough surface, but I'm not asking about the frictional force. And then there's going to be a displacement, so the displacement is going to be here, and it's going to be 3 meters. Now, what we know is that we find work, we say that the work is equal to the component of the force in line with the displacement, or the component of the displacement in line with the force. In this case, it seems to make sense to say F cosine theta times displacement. And what I do in my mind's eye is I visualize this component of the force, which is pointing backwards, and this is going to be minus 6 cosine 20. It is 6 cosine 20 because that's the way I get the magnitude of the component, and it is minus 6 because it's pointing to the left. In comparison, this would be plus 3 because it's pointing to the right. And so I say, okay, work is equal to minus 6 cosine 20 added to plus 3. Work is equal to minus 18 cosine 20. And that means that my work is equal to minus 16.9 joules. Now that's numerically. In terms of magnitude, that's the same answer I had to the previous problem. In the previous problem, I just said it was 16.9. It was positive 16.9. In the previous problem, let me just wind to it. In the previous problem, this force was actually putting work into it, this force was doing work which was adding energy to the block. So this block would go faster and faster and faster. Or if it was already traveling, it would speed up, it would go faster and faster and faster, assuming it was either stationary or traveling to the right. And this block, because it's traveling to the right but the force is to the left, it's going to be slowing down, which is taking energy out of the block. It's reducing its kinetic energy. This is analogous to sliding into first base. When your force is in one direction and your displacement is in another direction, you take energy out of the system because it's got negative work is being done by that force. Okay, so there we have it.